Alright, so this is the Exoplanet Lab. This lab is the mathematical portion of what you did before. We're going to look at some actual exoplanets and get some data to do some numbers about the various properties of the exoplanet. This looks a lot more technical than it actually is. You look at your sheet in front of you, it gives you all the pieces of data you're trying to gather for each exoplanet: distance, period, temperature, the mass, things like that. I'm going to do the first one for you, and then you're going to pick two other planets to do and follow the same mechanics. So you're going to click Make Observation. Excuse me, sorry. So you're first seeing this graph here. This graph is plotting how much light is being output per day. Again, it's going to do most of the math for you. You just have to be able to read the graphs and understand what it's gathering for you. And all this is in the words here, if you'll read through it, if I'm not being completely clear. At the top, it's keeping track of all the data we're going to be gathering. This is what you're going to be inputting into your table. And there's a few pieces you need here about the star that it's orbiting around. So your first task is to figure out how much space is between each of these lines. So we look at this first chart here. It cuts it off at about 80, but it starts about 5 in. So the distance here is 75. So that's about the extent of the math we're looking at here. So you're going to come down here and you're going to put in 75. I've already filled mine in, so it's going to auto fill them in. You'll note here it says automatic. Every time it says automatic, that means it's going to do the math for you. You just hit calculate, it'll give you the answer. So the period, the time it takes to get around its sun, is 0.2 years. And that's our first calculation. So if you follow along there, once you hit next, it's going to add it to the top of the page here, but you can go ahead and put that in your sheet. That'll be fine. Our next goal is to figure out the distance. So we need to figure out the mass of the star that it's orbiting. So this is an F5 star main sequence. We'll do stars in a few weeks, but for now it's an F5. Cool. So this chart tells you F5 stars are 1.4 times the size of our sun. Everything's based on our sun. So we're going to put that 1.4 in there, and it's grabbing that number that we already calculated up here, because again, it does all the math for you. Then you're just going to hit calculate. It's going to tell you the distance is 0.38 of an AU. So it's about the distance of Venus on our scale. So you're going to hit next, and again, it plots everything up here for you, but you can have a running total on your tables. That's fine. So our next up is habitable zones. Can you actually live on this planet? And this chart is a bit of a doozy, but basically you got to grab what kind of star it is. Again, this is an F5 star, so we're looking in this region. F5 goes down to the G, so it's somewhere around here. And then we want the distance in AU, which we said was 0.38. So we're using this scale down here. Now, this is log, so be careful. Each notch is stretched out a little more than it is. So we're looking at 0.3 is about here. We're coming up to F5, which is about here, where this M is. You'll note M is not in that green strip, which it's telling you is the habitable zone. Now you can click on this and make it bigger if you need to. That's fine. But the idea is that this plot of this star or this planet does not fall in the habitable zone. So we're going to put it is not in the habitable zone. Now when you hit evaluate choice, it will tell you if you're missing information, or it'll tell you if you get it wrong and tell you what to think about and look at to correct it. It won't give you the answer, it'll just tell you how to move forward. But we can evaluate that. It says good choice. Cool. So we can add that it is not in the habitable zone. So it says not in, or you just put no. Next up, we're going to find the surface temperature. So we're going to be reading this chart here that tells us all about the star itself. So again, we're looking at the F5. That's what our spectral type was for this star that we're using for our exoplanet. Gives us the radius is 1.2. And then we also need the temperature, which is going to go here. This is in Kelvin. And again, an F5 is 6,500. So the automatic's what we're looking for. That's going to be the answer. It's going to tell us temperature of the planet, which is 550. And that's all we need. So 550 Kelvin, pretty warm planet. That's pretty close to the star. So there you go. And there's some readings about that down here about the temperature scale. But we got our data from that, so we're good. Next up, we want the radius. How big is the planet? Now this one, it does all of it for you. It pulls all the pieces in. You don't have to really do anything other than hit calculate, so freebie. But it is basing it off of how big the planet is based on Earth and the percentage of light output. And you can read all that in here. It does all the math and shows you the derivation. But if you just want the answer, there it is. It's 9.83 Earths, so it's 10 times bigger than the Earth, which is what we'll need for a future calculation. And again, it's keeping a running tally up here at the top so that we can fill in our chart and move on. Now, these last two big ones are two different ways of finding the mass of the planet, of the exoplanet. It's using two different methods. The first one, they both use density, but one uses it based on the radius, the other uses it based on the distance. So again, automatic, when you see that, it's going to do the math for you, but it is looking for you to fill in something from the chart. This is the chart we're talking about. So we need to find the planet radius, and we just said it was about 10 Earths, or 9.8. So we're looking, again, this is a log scale. So we're looking at kind of close to the Saturn, a little bit below, it's dipping below that 1,000 line. So that first notch there is about 800. So we'll fill that in, and it'll give us our first mass is 138 based on Model 1. Model 2 is the same kind of calculation, but again, it's based on the distance from the sun, which we said ours was 0.38. So looking at this chart for 0.38, which would be way in this first little notch here, because this goes up to 10. So all the way up here, somewhere about 5,000. And you might be off like 5,100, and you can plug in different numbers. It'll tell you if you're right or wrong and how to better read the charts. But again, it does all the math for you once you hit the calculate button. So we have two wildly different answers based on these two models. That's kind of the point of this whole exercise, that exoplanets are kind of a mystery. We have models and tracking a lot of different planets out there and trying to figure out what they're doing. And what's a more correct way of calculating it, where it's based on how do we find these two densities. These are based off calculations that we did earlier. You know, which one's more accurate, and are there other planets that fall into that line, that model? Well, we can get into that this week with some of our discussions. And finally, it's going to look at probability of discovery. So there's a lot of planets out there, a lot of exoplanets, and this is based on a calculation of percentage on whether or not it's going to be producing that very first model where we saw the lines on the graph. Again, it's doing all the math for you, but it's about how likely are we to find an exoplanet of this style. And you'll see here that it does the math for you, 1.43%. If you had data summary, it'll give you that last page with everything on it. And we have filled out the whole chart. So that is star 1. Obviously, there's a lot of pieces to that. Feel free to go back in the video and pick this up. Or again, if you read each page, it'll tell you what each piece is and how to find it. But it's a little more denser on a calculation. So your job now is to go in, pick 2 other planets. There are 7 more. Not all of them have data. You'll see when you get that first chart. If they don't have any data, you can't use them. So go find a different planet. And you'll be doing 2 more for parent star number, the other 2 on your chart to fill them out. All right, thanks guys.